Hi everyone, in this video we are going to discuss the negative aspects of natural gas. So just like our other fossil fuels with coal and petroleum, there are two different components, or essentially negative pieces of this process. So the first one is you have to obtain it. So you have to drill to get the natural gas, there's some negative components to that, and then you also have to set the gas on fire. You have to perform a combustion reaction, and there are definitely some negative components to that as well. So let's start off with the most basic part, where how do we actually collect this natural gas and how is it negative? So the first thing we're going to talk about is something called hydraulic fracturing, which is more commonly referred to as fracking. So you may have heard of this before. So fracking is something that's really unique. In about the year 2004-ish, it really took off and we started to use this technology a lot to obtain our natural gas. And then in the year 2010, we peaked and we were basically obtaining the most natural gas per day than we ever had before. So in 2010, on average, we were collecting about 1 billion cubic feet of natural gas per day. So 1 billion cubic feet of natural gas per day. That's a lot. Unfortunately, fast forward a couple years, the last couple years, especially now in 2015, we are seeing some adverse health effects. So let me tell you how this process works, and then hopefully you can figure out what's happening and why that's so bad. So fracking is a very, very unique process. The first thing you do is you drill about 1 to 2 miles down below the Earth's surface until you hit essentially a pocket of natural gas. So you go all the way up to the pocket and then you stop drilling. Take the drill out. Now, the second step is you send in highly pressurized water. So this water shoots down and it's hitting onto this pocket, trying to hit it with enough pressure that it forces it to crack. Now, this is not pure water that we're sending down there. It is water that has been basically supplemented with a cocktail of chemicals. So there's a number of different chemicals in there. Plus, we also add some silicon dioxide, also known as sand. So we put chemicals in there, we have sand, and this is all in the medium water. So now, the water is going down, hits it, so pressurized that it forces these pockets to kind of crack. And so you have these teeny little cracks that start to form. Well, the sand gets in these cracks and basically forces it open, and so now you have all these gaps in this pocket and the natural gas starts flushing out. So you grab the natural gas and then you contain it. What do you think the problems are? Well, for the first part, we actually contaminate the water just willingly. We put tons of chemicals into the water. Then we shove that water 1 to 2 miles below the surface, and so all the way down there, anything this water hits, if it's exposed to any part of our environment or any part of the Earth's core, we are going to expose it to these chemicals. And so anybody who lives nearby is having serious issues with their health effects, specifically anything that have to do with their drinking water. So their water has been contaminated, and the fish in nearby ponds are dying. They are not surviving. And so even though this seemed like a great thing back in 2004, even though it was used before that, we are seeing some seriously negative pieces of it right now. So that's number one. Fracking, not the best option. Number two, we also have to deal with storage. Now, natural gas is a gas. Gas is super teeny tiny. So any form of crack, like if you have a pipe, any crack, that natural gas is going to escape. So you need to invest in very, very thick insulated containers that are going to be airtight, and they're going to make sure they keep all that methane contained. Second aspect of that is natural gas is extraordinarily flammable. So not only do you have to have proper containment, you need to make sure that there's no way it's ever going to be exposed to a spark or a fire, because then you will have a huge explosion on your hands, and that would be a disaster. All right, so that's storage. Number three, how about transportation? Like we said, natural gas is a gas, so it's going to be very, very difficult to move it from one continent to another. So let's say, for example, somewhere in England, they find this huge amount of natural gas and they want to share it with everyone for free. I don't know why they do that, but let's say they do. It would be extraordinarily difficult for them to send that gas over here to us in the U.S. There are pipelines. We are working on being able to transport it from continent to continent, but we are seriously struggling with it. So the transportation of natural gas is difficult just because it's a gas. Right now in the United States, most of our transportation is done underground in pipes. That's how we actually get our natural gas from a plant out to people's houses, so they can use the natural gas in their grill or maybe their stove or whatever it is you're using gas for, or to heat your house. That's a big one. All right, so that's a problem because it's gas, right? Number 4, and this is the one I always end on, when you're doing a combustion reaction, we are setting that methane on fire, so we are definitely creating carbon dioxide, which we know is a greenhouse gas. And so we know carbon dioxide is released into our atmosphere. As the carbon dioxide concentration is increased, we've definitely seen an increase in our global average temperature. So we are definitely experiencing the enhanced greenhouse effect, also known as global warming. So this is bad. The only silver lining, and it's teeny, teeny, tiny, is that the combustion of natural gas releases the least amount of methane in comparison to the other fossil fuels. So if I were to rank these in terms of carbon dioxide concentration upon combustion of these fossil fuels, we would say that natural gas releases the least amount, and then we have petroleum, and we have this jerk over here, coal, who releases the most amount of carbon dioxide. And so these two are about twice as much that as carbon dioxide, or excuse me, of the natural gas. And so the petroleum and coal are significantly worse. So let's ask a question to see if you followed this big long tangent I just went on. Which fossil fuel burns the cleanest? What do you think? Talk to your neighbor if you're lost. All right, did you get an answer? Hopefully you did, and the correct answer absolutely is natural gas. Natural gas burns the cleanest. So what I mean by that is it releases the least amount of carbon dioxide into the atmosphere. So it's the least offender in terms of global warming. Now, if I had a gun to your head, that sounds awful, but let's say I forced you to choose which fossil fuel out of natural gas, petroleum, and coal would you use if you could only pick one for the entire United States energy source, which would you pick? Well, hopefully you would say definitely natural gas. And here are the 2 reasons why. The first one is it burns the cleanest. It does not release that much carbon dioxide into the atmosphere relative to the other 2. But it releases the most amount of energy upon combustion if we're just comparing 1 gram burnt of each. So have a great week. Take care of yourself. Drink water.